been my background. I've been in the private sector almost my whole life as a consulting engineer. So a good example, our clients that I work for are, cities, counties, the federal government and whatnot, and I help, as Mr. Schwartz said, on water and wastewater is primarily my specialty. But what I want to do today is give a presentation that kind of is very broadband, and I think that a lot of this will glean out of this any type of technical career or project that you might be involved with. So you could flip the slide for me. So like I say, civil engineering, that's near and dear to my heart. It's super broad in terms of the type of work that you do. A typical civil engineer is, building, structural, stuff like that. I don't know how to design a building. I don't know how to design a retaining wall. But, my world is designing water treatment plants and wastewater treatment plants. So a lot of chemistry, a lot of mechanical. I interface a lot with electrical engineers, with structural engineers, with instrumentation type folks and whatnot. But civil engineering includes roads. You got to plan how you're going to, build your roads. How I-80, how much traffic's going to be on it. When they're looking at putting a new bypass in and something like that. That stuff all has to get thought about, and there's a lot that goes into these projects. In civil, there's construction careers where people focus and work primarily on construction management. They're on sites all the time dealing with contractors. One thing about civil engineering, they're generally really big projects. That's one advantage like a mechanical engineer might have, is you can build a prototype and you can test it. And we'll talk a little bit about the design thinking process. In civil engineering, you get one shot. You pour a lot of concrete and it better work, when you're done, because it's really hard to go back. Bridges, solid waste is a whole aspect of civil engineering. You don't think about it, but there's a lot that goes into a landfill in terms of how much waste, what can you recycle out of it, the gas systems that come out of it. Those are all civil engineering. Matt, his dad works for a geotechnical firm, tunneling. I'll talk a little bit about that in a moment. If you could flip for me. Oh, there you go. So I'm going to speak on civil engineering. Who wants to be a civil engineer? Is there anybody? Well, maybe I can convince you otherwise. Mechanical engineers? There we go. All right, mechanical is awesome. How about chemical engineering? All right, electrical?
No. I was going to do like petroleum engineering.
But yeah, that's total chemical engineering. I mean, super complex. Petroleum plants are amazing. I've worked in remediation projects on those, and you go into those facilities and it blows your mind how those can even operate. But there's so much complexity, in a petroleum plant. It's amazing. So from a technical standpoint, I'm going to just gloss over these because it sounds like you guys are more the mechanical end. But as a mechanical engineer or a chemical engineer, even electrical, you'll find that you may end up working on civil type projects because that's a huge component right now. You figure 25% of a project cost is going to be electrical and instrumentation nowadays. I mean, it's huge, and that's been driven by advances in computer technology and software and instrumentation. These plants are so automated now. But Mr. Pfeiffer John, he's a geotech, and whenever I start a project, one of the first people I have to consult with as a general civil is, hey, what are my soils like? This project here, I was just at a site, yesterday, and this is just a pipeline job, right? It's taken 8 years, and it's finally under construction. And the geotech on that was huge. It was a project that was down in the Delta, so you have these really loamy, peaty soils. So if you put a pipe in there, what's going to happen? Well, it's going to try to sink, right? And you have to understand that so you can design the piping system. And the geotechnical engineers were huge on that. Structural, I think everyone's got a pretty good feel on that. Buildings in California are huge, right, in terms of seismic issues. Now they're finding down in the southeast as climate change, whatever's causing it, but we know it's changing tornadoes and whatnot, so they're having to revisit how they build structures and how they react to high wind loads and things of that nature. Environmental, that's kind of my world, water, wastewater, and in transportation. Those are kind of some of the major categories in the civil world. But regardless of whether you're a chemical engineer, regardless of whether you're a mechanical engineer, generally, and even if you're not an engineer, but you're in a technical field, generally what can and oftentimes happen is you start working and you're doing a lot of basic engineering or technical type work. It might be going out collecting samples, coming back, looking at the data, you know, on water quality data. It might be out mapping, and you'll get really good at that technical stuff, and hopefully the senior, you know, folks that you're working for, they're going to mentor you, and then over time you're going to start mentoring somebody and so on. And oftentimes in a technical career, there's kind of this branch where you'll go from being pure technical to starting to move over into the business end of it, right? And that could be a project manager. Believe it or not, the management end of any sizable project is huge. Planning it, monitoring it, the quality of the work, interfacing with the client if you're in the private sector, interfacing with management of a big corporation at a petroleum. Hey, why do we need new cokers? Well, because these are going to fail. Well, why do we have to spend $3 million? Well, because if we don't, it's going to fail, and we're going to have an environmental disaster. People are going to get hurt, and we'll have better efficiency if we do it. You're going to have to convince management, you know, on that. So there's also the marketing end of it, right? Particularly if you're in consulting, you have to go out and compete for jobs. Nobody gives you jobs anymore. So you have to go out and, using your technical knowledge, you're going to have to go explain to, you know, that client why your firm is qualified, why your firm is better than all the competition, right? So it's huge. Marketing is a huge aspect of, believe it or not, technical work. There's also kind of contracts and risk management. So I work a lot with attorneys, and mercifully, knock on wood, lots of wood in here, I've never, you know, I haven't ran into being on the back side of an attorney. It's on the front side. It's planning a project, making sure the contracts are written correctly to provide, you know, to provide me a fair shake at it and the client a fair shake at it. Also, a lot of technical people kind of move into the finance end of it. There's a lot of mechanical engineers. There's lots of engineers out there that have gone through this phase of their career, and then at night, or they've gone back to get MBAs. I mean, having a technical background and in a business background is very, very, very powerful in terms of being very effective, and that's usually something that happens later in your career. And lastly, there's kind of the policy and, you know, regulatory, you know, type end of it. You know, you might be a lobbyist, right? You might work for you know, a government GAO, government something association, organization association, where it might be Friends of the Yuba River, right? They have they're essentially an environmental watchdog group. And there's places, I have a friend that I used to work with, she's in finance, and she's now she's like the CFO of Circle. It's an organization over in Yuba, you know, related to the protection of the rivers. And then, so now you got all these career paths, you know, where are you going to work? You know, so there's really three real big categories. There's the private sector, which is consulting. It might be working for Chevron. It might be working for Ford, designing a drivetrain of the new Ford Raptor. You know, you don't, you know, there's lots of opportunity both in consulting and industry out there. The next big category is the government, and federal government, all the way down to the state, to the county, to the city, and to special agencies. Like a good one would be Placer County Water Agency. They're a huge employer here in Placer County, and they've got environmental specialists, they've got water quality specialists, they've got engineers, they've got finance people with technical backgrounds. So, you know, it's wide open in terms of private sector, government, and you might find you want to be a teacher. You know, that's kind of my, you know, was one of the things that I really wanted to do, you know, growing up. And you might get into research at a university level, kind of pushing the industry along, you know, in terms of developing, you know, new means and methods of doing things better and more efficiently as technology, you know, moves forward. And hey, if anybody has any questions as we go, just, you know, throw it out there, because, you know, it's easier to catch them now than it is, you know, at the end. So if you want to hit the slide. So, okay, all that, you know, careers, where you're going to work and all that. Talk a little bit about the day of a technician or engineer, something like that.
When you say technician, you mean 2-year degree?
I mean, I should say just a technical background, technical degree. You know, I consider myself kind of a technical person, right? So well, let me back up. There's a lot of people, and maybe we'll get into that here in just a sec, actually. You know, kind of the support behind, you know, these drawings. I don't do these drawings. You know, this is a drawing set, and unfortunately, the world that we've run into now, this is kind of the technical. So this is what the contractor bids the project based on. He says, hey, it's going to cost $2.5 million to do this project, right? Well, there's a whole nother set of documents that go with this, and it's called the specification. So it talks about, it's a lot of verbiage on how you have to do stuff and the kind of material that these pipes are going to be, not necessarily how to build it. And unfortunately, I'll just come out and say it, unfortunately now, so much of what we do is the legal end of it, because we live in a very litigious era. It's just the way it is. So people are always trying to cover themselves to make sure. So there's another book that goes along with this that's about that big, and half of it is all kind of legalese. It's all contract stuff and stuff like that. It's just the world that that we live in at this point. Can I set that there? Thanks. So anyway, the thing I use the most is a calculator. I mean, I have 3 or 4 of them sitting around my desk. I'm on the phone, I'm talking to somebody, I got to do something really quick. I'm not good with numbers in my head. You guys are probably a lot quicker and more up on the math end of it than I am. But calculator spreadsheets, that's probably the go-to tool. We use spreadsheets for almost every sizable project to do analyses quickly. So are you working on spreadsheets here? I know my son Griffin goes to school here, and he has like a Google version of it that I see now and then. So who's got familiarity with them? Yeah. Hey, any chance you get, get good at them, because it will save you a ton of time, and they're very powerful. Moving from kind of a generic software, Microsoft Excel, Microsoft Word, that kind of stuff, there's a lot of specialized software out there now that really speeds up the process and of doing these designs. I mean, everybody, hydraulic modeling. So let's just say that there's in city San Francisco, imagine the pipe network of water, getting out to customers, the sewage getting away from their houses to the sewage plant, the storm drain system and all that. It's almost, it is impossible to calculate that by hand. So you use a lot of hydraulic modeling package software. These are pretty expensive, they're $5,000-$10,000 for kind of a limited version of it, right? There's groundwater modeling, there's structural modeling, traffic modeling. When you guys get into mechanical engineering systems and whatnot, I'm sure there's a whole set of specialized software, and that's something that I'll warn you right now. It's really cool stuff. When I started working, is it back one? When I started working hydraulic modeling, I just loved to do it, right? You got to be a little bit careful. You want to this is my opinion. You want to be able to know how they work. You want to be able to sit down and use it. But I've also had friends that kind of pigeonhole themselves, and that's all they do. And fortunately, there's people like that. Some of them have gone crazy, and I had one friend that actually left the firm I was working. He said, I'm going crazy here, sitting here working on these models. They're really cool, they're really powerful, and I'd advise everybody to use them, but just be careful in your career. You don't, unless that's what you love to do, right? You just might want to be the best hydraulic modeler, but it's easy to get pigeonholed in some of these, and if you're really good at it, it's really easy to get pigeonholed, because your supervisor can be, oh, hey, Matt, hey, could you... But they're fun and they're interesting, but I'll talk a little bit on the next slide about the data that goes in, because what goes into these versus what goes out is a whole another can of worms.
So if I may interrupt, so when you say pigeonhole, you mean you're so good at it, you don't do anything else on the job site. Yeah. So you end up sticking yourself in front of a computer.
That's correct.
And cutting yourself out of potential advancements.
Exactly. And my personal opinion is, to advance in the technical world, you want to be a master of the technical stuff. You have to be, okay? But then, unless you're going to be like the best of the best, you're going to go get a PhD in, finite element analysis, and write textbooks and be that person. I personally think it's better to get really good at the technical stuff, and then that non-technical branch, get into the client management, the proposals, the project management. Those, I think it's a more personally rewarding career, because you're dealing with people, you still get to do the technical stuff that you love, but you're not stuck doing hydraulic modeling your whole career. That's just my opinion. And some people, I have friends that's all they do. They're like GIS specialists. That's all they do is GIS, and they love it. So my bent was to move a little bit out of the technical. I still do a lot of technical work, but more than that. And I personally think it gives you more options for growth in the industry if you're willing to take that end of it on. In terms of support packages, and maybe Mr. Schwartz, I gotta call you Jonathan, it sounds better. The technician end of it, you know, we do have like called engineering techs, you know, some of them have 4-year degrees, right? And they're really good. And they're the ones that I size the pipe, I do a schematic, I kind of lay it out. They're the ones that do the magic of laying it out. They're the ones that do the 3D modeling of a plant, right? To show a visualization of what everything's actually gonna look like. You know, hey, that valve's not gonna fit here, Jerry, we got a problem, right? So, in my career, I learned AutoCAD. I used it for a number of years, but then I kind of quit using it, and now it's changed so much I don't use it. I have folks that help me with that. Revit is a brand, and it moves into this BIM, Building Information Modeling. And what we're finding now is a lot of the big infrastructure that was constructed was built in the 50s, 60s, and 70s. There was more money around at that time. There was big federal grants that would build these big projects, big road projects and stuff. Guess what? The money's not there anymore, and guess what else? All of these projects are now kind of reaching the end of their design life, and everything's falling apart. So as a result, there's a lot of operation maintenance costs that go into it. And these BIM programs, like on a building, is no different, right? These BIM programs are not only used for building, but it's information management. So now, whoever is the building supervisor, right, they have a whole inventory on the age of the pipes, all the maintenance they've done on all the cooling systems and the heating systems, on the elevator systems and whatnot. And they actually use it now as a budgeting tool to take care of this huge, potentially billion-dollar asset, right? So this moves from the design and construction into long-term management of a huge asset. And then 3D modeling, stuff like that. Then GIS, I mentioned that. Does anybody, Geographic Information System, anybody worked on one of those yet? It is by far, if you're going to do any type of planning, any type of regional work, any type of like data analysis related to the environment, it is the most powerful tool out there right now. It's absolutely incredible. I don't know if anybody knows Dan Stevens. He was a graduate here. He went down to college. He came back. He's helping us out at Hydros Consulting right now, and he's becoming our GIS expert. And we were just working this morning on an online map of some water systems. It's really cool stuff. And then there's kind of the support stuff. There's, you know, all the stuff you use to put together your reports, and then the accounting end of it, right? I'm in QuickBooks almost as much I'm in, you know, managing the companies and the finances and all that as I am the technical stuff. So, how are we doing on time?
About 10 minutes.
10 minutes, okay. So, data. So this is kind of how this whole conversation got started, was data. We live in the information, you know, technology world, right? When you're doing a project, you got to find data first, and there's lots of different sources of data. You know, it could be from government sites, from federal government, all the way down to, you know, a local agency. You could buy data. You know, you can hire somebody to go out and collect it for you, and then your clients are going to be a big, you know, source of data. At least in my world, like a water treatment plant. You know, I need flows and loads of the plant. One thing I'll advise you through your career, I don't care what you're in, question the data. You know, you got to understand that it's only as good as the instrumentation that was collecting it, or the person writing it down off of a piece of equipment that may or may not have been calibrated in a year or two. A great example is right now, if I got asked by, you know, the city of Downeyville, hey, you know, could you do a water master plan? And hey, here's 3 years of water data that you can use. You know, what do you think with our drought? You know, how good is that data going to be? It's not good. It's not representative of long term. So you got to look at it. You got to be skeptical with it. You got to wonder how the format is going to be. Are they going to show up with a box of papers and go here? Or is it going to be in an Excel file for you? You know, those are all questions to ask, things to try to understand about the information. Then how do you manage it? I mean, we get gigabytes of data now, you know, well, now what? You know, you got to understand how you're going to, who else is going to use it in your company? Are you the only one using it? Are you going to change it? And then all of a sudden, you know, it's no good for somebody else. I mean, we've had that happen, and we spent days sorting out data that got not corrupted, but got modified and wouldn't work in these specialized software programs because somebody didn't know. A lot of times there's no data, and you just got to use judgment. You know, it's been the point where you have to just go to kind of textbook numbers because the information you have just doesn't make any sense. And as you get older, you kind of get a gut feeling for it. I mean, don't get me wrong. I mean, I still get stung all the time. You know, I'm looking at stuff and I misinterpret it. But that's why you check and double check. So let's go next slide. So one of the things that you talk about here is the design thinking process. And, you know, when, you know, Mr. Wolf and Mr. Schwartz, you know, they showed me some videos once. I saw some up on YouTube, and they'd kind of talked about it. And is that still an ongoing effort here?
Yeah.
Okay. Hey, because it really hits the nail on the head, and I wanted to use a brief example local here. I didn't work directly on this Colfax project, but I know a lot about it. And, you know, they had a problem, right? They had a wastewater treatment plant that wasn't meeting discharge requirements. It didn't have enough capacity. They were getting sued by private folks. They were getting, you know, fined by the state regulatory agencies. It was a big mess. So there the problem was easy to define. So then, okay, so what do you do? You know, how are you going to approach this? Well, hey, what are we working in? Particularly in their case was, you know, how much capacity do they ultimately need? You don't want to spend $3 million on a project and then find out that you didn't talk to the city and understand that that city is going to grow. And hey, we didn't need half an MGD, we needed a whole MGD of extra capacity to go on this. Now we got to go back and do it again. So you need to talk to your client. Your client might be internal. It might be somebody that you're working with or another team in your company, like using a car. You know, the people working on transmission have to work with the people on the engine. You got to collaborate, you know, between there. So the engine drive folks might be the transmission person's, in essence, client. So you got to understand what they need. A big one in our world is, you know, the cost, you know, of these projects. I mean, how much money, you know, might be available? What level of treatment is necessary? How soon do we have to get this thing done? You know, are there consequences if we don't get it done in time? So you kind of define, you know, the box that you're working in with your constraints. And then if we hit that slide, then you develop a plan. You know, now what are we going to do, right? We've got this, you know, we understand the problem. We understand, you know, how fast we have to get done, how much money we have to work with. Now we're going to develop a plan on how to execute this thing. How do we move forward, you know, with the plan? And a big one is scheduling. That's that whole concept of project management. As you move through your career, you become kind of a manager, making sure, hey, are all the teams doing what they're supposed to be doing? You're interfacing with other firms, you're interfacing with your client. So you got to lay out a critical path and know what's the most important. Then in the city, in the case of the city of Colfax, they had to raise wastewater rates. Never popular, never popular. Politicians, the city councils hate doing it. So that has to get implemented because you can't just raise them overnight. And then environmental constraints. I mean, are there areas of the site that we can and can't work? Then lastly, then you put together these, right? The design documents. You put them all together. You put it out to bid. There's certain rules and regulations that you have to deal with, you know, when you're dealing with public money on how you bid these jobs. You construct it. Hopefully it all goes right. And you start it up. And hopefully it works. It better work, right? So in your design, you know, thinking, you know, you develop, you identify the problem, you come up with your constraints, you come up with a plan, you execute, you check, right? For me, the check is when we open up the valve. Does it work? But that being said, this is design thinking on a big basis. There's a whole bunch of little do loops in here. We're doing that at every stage. When we're developing the schedule, you know, are there any problems? You know, oh, we got some constraints. Okay, hey, we need to adjust. And you're constantly going through checks and balances all the way through this in that design thinking, you know, philosophy as you go through. So when you guys talk about that, it's real stuff. It's really used out in industry. So I got a couple more slides here. I don't care what you're doing, you know, in the world, these kind of go through. I mean, I just turned 50. I feel like I'm got enough gray hair and can kind of, these are things that always bite you. Budgets are always a problem, whether it's internal budget, do we have enough money to finish the project for the client, or does the client have enough money to do the project that they need? Lack of resources, and that could be staffing, it could be money, it could be time, it could be equipment, it could be software, it doesn't matter. Scheduling, there's never enough time. There's always something that comes up. When you do these schedules, you got to build a buffer in. You have to do it. Project opposition, well, you know, there might be special interest groups that don't want you to build this project. There might be landowners that don't want you to have an easement through their property. There might be cities, in this case, that don't want you to do a project for a neighboring agency. There's always opposition, and sometimes it's internal, right? At Ford, that engine thing, the engine people, you know, hey, the transmission's not as important as our engine, right? And so they're kind of opposing you for internal resources on the company. Red tape, it's going to be there no matter what you do. Regulations are just, they're skyrocketing, and you got to be aware of them. And miscommunication, this is a killer. This kills you all the time. Not communicating with your team member internally, not communicating with your supervisor, with your client, with outside special interests. You've got to be a communicator. And then the next slide, this will wrap it up. I think that these are some, if you leave here remembering anything, remember this slide. First, you guys are young, man. You have so many good things in front of you. Pick something that you love and don't be afraid to change. I was going to be a geologist. That's what I was going to do. And I changed my mind, and I was so bummed. My dad's like, Jerry, it's not wasted time. This stuff will be good. And it turned out I use my geology background all the time, right? Because I'm working with underground stuff. And don't be afraid to make shifts. I was at a JC for 6 years figuring out what I wanted to do. And I went from everything from being a geologist to wanting to be an underwater diver, welder, to being a psychologist, and I just circle back to that technical stuff because I just enjoy it. But take your time and get it right. And it's going to be hard work. I mean, if you're in any kind of technical stuff, grind it out. I assure you it'll be worth it. When you run into problems on projects, don't avoid them. I mean, the thing that you don't want to do is usually the most uncomfortable, right? And it's uncomfortable because it's a problem. Address it. You'll sleep better, and just get it behind you and move forward. Common sense, compassion, and honesty. I mean, our companies that I'm involved with right now, our motto is be honest, do great work, and have fun. And the rest will follow. So you got to have some core values. People, I put common sense. It's not that hard. This stuff isn't that hard. Think about it, work hard, understand it, and it's not rocket science. It truly, putting a man on the moon, that's rocket science. But in the world that I run in, it's a lot of just common sense. Compassion, help your peers succeed. All boats are going to rise with the tide. You're going to find as you get older, people want you to succeed. They really do. And lastly, and one of the most important things, I'd rather have somebody that can communicate well than to be the best engineer out there, because you can have the best answer on paper. If you can't convey that answer to somebody and convince them, it doesn't matter how right you are. You got to be able to convey why it's important. So sorry I ran out of time for questions, but anyway, thanks everybody.
Thank you.
All right.